Getting humans to Mars, it's the dream, right? It's the grand ambition of our time, that next giant leap for humanity. But here's the thing. While we all agree on the destination, how we actually get there is one of the biggest debates happening in space exploration today.
So let's just get right into it. What is the best way to get humans to Mars? Do you just point a giant rocket at the red planet and go for it? Or is there a smarter, maybe more strategic way to do it? This one question is at the absolute heart of how we're planning to explore deep space.
And it really boils down to two big ideas. On one hand, you've got the direct route, the one championed by folks like SpaceX. It's bold, it's fast, it's a straight shot to the Martian surface. Then, on the other hand, you have the pit stop route. This is favored more by NASA and legacy players like Boeing. It's a more cautious step-by-step plan that involves setting up a kind of base camp in orbit around Mars before you ever try to land.
And the prime location for that base camp? Yeah, this thing. This strange, lumpy, wobbly rock. It's Phobos, the larger of Mars's two moons. Now, it might not look like much, I'll give you that, but it could just be the secret key to unlocking the entire red planet for humanity.
So here's what we're going to cover. First, we'll dig into why Phobos is such a great strategic location. Then, we'll look at the real-life robotic mission that's already getting ready to go check it out. We'll also unpack a huge scientific mystery it could solve, geek out on the cool tech they're using, and finally, we'll touch on the all-important rules of exploring space responsibly.
All right, let's start with that big idea. Why even bother with a pit stop? What makes this strange little moon so important? Well, Phobos is so compelling because it solves a whole bunch of problems all at once. First, safety. Mars itself acts like this massive radiation shield, blocking about half of the dangerous cosmic rays that would otherwise hit a crew. It's also a perfect low-gravity sandbox to test out tech we're going to need for things like asteroid mining. And maybe, most importantly, it lets a human crew get used to the entire Martian system before they attempt the riskiest part of the whole mission, actually landing on the planet. Now, this isn't just some hypothetical, far-off idea. Japan's space agency, JAXA, is actually leading a mission to put this whole theory, and Phobos itself, right under the microscope. It's called MMX, the Martian Moons Exploration, and its goal is incredibly ambitious. Visit Phobos, land on it, scoop up a sample, and bring it all the way back home to Earth. Think about that. This would be the very first time we have ever brought a piece of the Martian system back here. And believe me, this is a long game. After launching in 2026, it's going to take about a year just to travel to Mars. The spacecraft will then spend several years studying Phobos and grabbing its sample before making another year-long journey home. That precious cargo is scheduled to land back on Earth sometime around 2029. But, beyond all the strategic stuff, MMX is trying to answer a huge scientific question that has puzzled astronomers for decades. What exactly is Phobos? Where did it come from? Okay, so there are two main schools of thought here. Theory number one is that Phobos is just a captured asteroid. A stray rock from the outer solar system that just wandered a little too close to Mars and got trapped by its gravity. But theory number two is way more dramatic, that it was born from a giant impact. A massive object slammed into a young Mars, blasting debris into orbit, and Phobos formed from that debris. Kind of like how our own moon was formed. Those samples that MMX brings back, they should finally tell us which story is the right one. And this is super cool. This shows exactly how MMX is going to find the answer. It's using this dual-pronged attack. It's got two different samplers. One will basically skim the very top layer of dust, which might contain material that supports that captured asteroid theory. But the other one is going to drill down deeper to grab the original, pristine stuff that could only have come from Mars itself. It's brilliant. So how is MMX actually going to collect these samples? Let's geek out for a minute and look at the incredible engineering packed into this spacecraft. So here's that two-sampler system again. The P-sampler is pretty much a cosmic vacuum cleaner. It shoots out a puff of nitrogen gas to kick up the freshest dust on the surface and then just sucks it into a container. The C-sampler, though, that's a coring drill. It's going to dig down more than 2 centimeters to get a sample of the moon's original building blocks, totally untouched by the harsh environment of space. MX is also bringing a friend along for the ride. This is Idefix, a little rover built by the French and German space agencies. It's going to be dropped right onto the surface to act as a scout, analyzing the regolith, that's the layer of loose dust and rock, up close, and helping the main spacecraft pick the absolute perfect spot to grab its sample. But trying to operate on Phobos is unlike anything we've ever done. The gravity there is so weak. I love this quote from Boeing's Matt Duggan. He said, "You don't really land on Phobos. It's more like a docking.
You literally have to cozy up to it and use anchors to keep from just floating away. One little mistake and you could go tumbling off into space.
But with all this amazing science and exploration, you can't just go zipping around space doing whatever you want. It all has to follow a pretty strict set of rules designed to protect both the worlds we visit and, well, our own.
This whole idea is called planetary protection, and you can think of it as a two-way street. First, we have to avoid contaminating other worlds with our Earth germs, because that could totally mess up any future search for alien life. And second, we have to protect Earth from anything potentially harmful in the samples we bring back.
And this isn't some newfangled idea. It's actually written into Article 9 of the Outer Space Treaty of 1967, which calls on all spacefaring nations to avoid harmful contamination both out there in space and back here on Earth.
So for MMX, this all breaks down into two risk categories. On the way out to Phobos, it's a Category 3 mission. We have to make sure the probe is incredibly clean so we don't accidentally bring any Earth life with us. But for the sample coming home, it's considered Category 5, which is the highest level, but with this special note: unrestricted Earth return. And that's because scientists are pretty confident the risk of Phobos having any life is so low, we don't need one of those super secure Andromeda strain-style labs to handle it. So when you put it all together, you see that MMX is so much more than just one mission. It's a technology test run, it's a strategic pathfinder for human exploration, and it's a deep scientific investigation all rolled into one.
Which really leaves us with one last big thought. It might just be a small, misshapen rock orbiting Mars, but by being our base camp, our science lab, and our training ground, could this tiny, wobbly moon actually turn out to be the most important stepping stone in all of human history?